This is going to be a brief introduction to the BioNect toolbox. So to start off, we'll just type BioNect, hit agree, start, and we'll be presented with two options. One is to load an existing configuration, if we've already set up our analysis at some point in the past, but for now, let's create a new configuration here. The next window will be our time analysis settings, so the percentage of data we want to use. Let's say we want to use all of our data. And we can also select which channels we want to use, either a range of channels or specific channels. And we can also set what time ranges in our data we want to look at. And if we're unsure of any of these settings, we can just look at the load sample file here, and what will pop up is the settings from a certain .z file. So we can see what channels are available as well as what time ranges. Oops, this should be 1000. If we want to remove one, just hit remove here. And next will be our frequency ranges. And let's say we want to look at theta. And as well as our task that's associated with our data. Let's say it's resting state. And we can specify which phenotypes our data consists of. It can either be one group or two groups or three groups, depending on what sort of analysis we want to do. And we'll also specify which number group is our condition positive group for any sort of data visualization we do at some point during our analysis. So I hit finish there, and let's just save it. Yes. Okay. So now, what pops up here is our main BioNect window. There's a number of different menu options here, but let's first look at the file menu. Here we can either select a new analysis file, which is the process we just went through, or if we want to load a file we've already made in the past, we can load this here. And at any point during our analysis, we can save what we've done so far and then come back to it in the future. And if we want to look at the settings we've just made, we can go to configuration settings here under settings. And if we don't like the settings we've made, we can make adjustments to them here and then just hit save and update. So the first thing we'll do here is to create a new batch file. The batch file will contain a list of all of our data files and their locations and any sort of specifics that are associated with them. Let's create a new batch file here. Let's put it on the desktop. Let's name it test batch. Oops. Test batch 2. Okay. So here it popped up. The first column will be the folder that our data is contained in. So each row will be associated with one specific .set file that we're interested in, including in our analysis. The next column will be our .set file and its name to be processed, which means we can either select it as yes or no to be included in our connectivity analysis. The process column will be set to 1 once, or it'll be set to 1 automatically once our connectivity analysis is done on that data set. Time range and montage name, don't worry about those columns. Phenotype, we can set what phenotype our data is associated with. The subject ID, so we can refer back to it in our analysis. And what sort of task our dataset consists of. So don't save. Here we've loaded a previously made analysis file. We've already looked at the file and settings menus. And under the run menu is all of our analysis steps. So for step 1 we have our connectivity. analysis. We can either look at it between single electrodes or between clusters of electrodes, depending on what sort of analysis we want to do. If we're interested in clusters, we can come over here to settings and define our clusters. And here we can set our cluster names as well as what channels are included in our clusters up here. After step 1, we can load all our data into MATLAB. We can specify where our data is located, the folder, and it's important to note that for this toolbox, all of your data should have the same channel order. So if it's not consistent throughout your data files, you can select the second option here to specify a custom channel order, which will reorganize your data for purposes of this toolbox. And if your data does have a consistent channel order and you want to keep it, you can select the first option here. After loading your data, we can run our graph theory measures. Here we can select different thresholding methods that we want to use. We can binarize our matrices if we're interested in that. And down here are a few options for our thresholding. Next, in addition to graph measures, if we're interested in power measures to be included in our analysis, we can select them here. We can specify our frequency bands, our electrodes, which we want to calculate our power over, as well as our time ranges here. For example, 100, these 3 electrodes, and these will be saved, and our absolute and relative power will be calculated for these specified settings. Now, we can run feature selection. After we've calculated either graph theory measures or power measures, we can choose which ones we want to include in our feature selection here by just checking these boxes. Hit confirm, they'll pop up down here. We can select the number of top features we want to use through our feature selection method. And there's a few feature selection methods we can use here. One is individual combos, which will use every combination of task and frequency down here. So for example, the tasks here are 1 dot, 3 dot, 5 dot, 7 dot, and we have multiple frequencies here. It will calculate top features, for example, 1 dot theta, 3 dot alpha, 5 dot beta, 5 dot theta, and all the unique combinations here. On the other hand, if we're interested in features that may be combined between certain tasks and frequencies, we can select them down here. For example, if I just want to look at top features from 1 dot and 3 dot theta frequency, then I can select them here, and it'll extract the top 3 features from this combination. Otherwise, if we have some features we are interested in just testing, and we don't want to use any sort of selection methods, we can come over to our third option here, which is create a feature set, and hit this button, and we can select which settings we want to use. So we can select our graph measure from a specific task and specific frequency, as well as type in here, and just hit add, and these will create our feature set here. There won't be any sort of feature selection being used. And for spectral power features here, since I didn't actually calculate them here, they're not available, but if you calculate them, they will be available here. Last is our classifier. Depending on the feature selection method we used, we may or may not be able to select which tasks and frequencies we want to run our classification on. And for our classifier here, there's a number of options we can use. We can further reduce our feature space with PCA. We can select a type of classifier. Note that all of these are included in SVM classification, but they're just different methods to use. And here we can set specific settings. Let's use k-fold cross-validation and set run. And depending on how many features you're using as well as how many iterations you're using, this may take some amount of time. So in your command window, you'll see that it'll write down what you ran the classification on, the accuracy, sensitivity, specificity, as well as write to a log file these results, as well as the settings that you use to obtain those results. And under the view menu, if we want to have some visualizations of our data, we can view connectivity maps. And here we can manually adjust our thresholds to visualize on a head map or raster plots, as well as on brain maps here. So you can see that as the connections change on our head map here, they'll also be mapped on a picture of the brain here for easier visualization. And down here we can view an average of all subjects, which is what this is, or we can view individual subjects and select subjects and phenotype, task, subbands, and as well as time ranges here. And if you're interested, you can also save any of these pictures with these save buttons. Next we have our graph measure plots. If we're interested in looking at how certain graph measures are associated over the brain, for example, we can look at modularity, and we can see that the purple dots here are associated with one module, and the gray dots associated with another module here. And again, we can go through subjects and see how these measures change across subjects. And lastly, we can export our data. So we can also export either our top features we calculated through feature selection or that we manually selected, or we can export the complete feature sets for any sort of statistical analysis. In addition, we can export to Weka, which is a third-party machine learning program. So if you're interested in using more advanced machine learning techniques for your data, you can export them here and use Weka. And lastly, we can export measure significant plots, which I'll show you a picture of in a second. And we can plot measures versus time, frequency, and task. We can set our significance level. We can select whether we want to use global measures or local measures. And this is what the plots will look like. So we have our frequency and task here. We have our time ranges, and we have our group averages of specific graph theory measures, as well as any significant differences between groups marked here.